All right, so we're just going to quickly remind ourselves what we're looking for each one of these terms, because these are the features of functions that we're going to be concerned with. So domain is our possible x values. Range is our possible y values. When we are looking at the graph, how can we tell that the function is positive? That is increasing above the x-axis. And so negative is below the x-axis. And then for increasing, that's going to be where we're going up, left to right, and decreasing is going down. Again, left to right. So these are things that we have already looked at with our log and exponential functions, right? So we're familiar with this stuff, but today we're going to look at some different types of functions that we're going to see. What I will do on the quiz, first of all, on the quiz, a question will only ask you one thing. So it might say, what is the domain of f of x equals square root of x plus 4 minus 2? So you will only be asked one question, not all 6 at once. And you, I will also put a picture of the graph like I have done here on the notes with it. You cannot use Desmos on the quiz, but I will include the picture with the graph so that you can look at that like you would in Desmos. Okay, so we are going to be looking primarily at square root functions, rational functions, and I think I threw a linear in here, natural log in here, but mostly square root and rational, because those are the types of problems that we're going to look at, or we're supposed to focus more on in pre-calculus. Quadratics are always continuous. They're your cubics are always continuous. They can be interesting to look at as well, but they're not ones that we have to spend a lot of time on here. So you're going to mostly see square roots and rationals today. And on the quiz, square roots, rationals, or possibly natural logs or exponentials, which we've been over before, might be there. So when we talk about domain for a square root, even if we did not have the graph, the radicand must be greater than or equal to 0. The radicand is whatever fancy thing you got underneath your square root, right? It's a fancy word for whatever's underneath the square root. So like for this particular problem, even without the graph, I would say x plus 4, the stuff underneath the square root, has to be greater than or equal to 0 because I don't want any negatives under that square root. And so I would just move the 4 over, and I'd have x is greater than or equal to negative 4. Let me look real quick at the quiz and see if I used interval notation for. Yeah, it looks like I used interval notation. So you could write it as x is greater than or equal to -4, but I used interval notation. So how would we write that using the interval notations with the brackets and the parentheses? We'll have -4 to positive infinity. Did I use a bracket or parentheses with my -4? Oh, sorry. Did I use a bracket or parentheses with my -4? Okay, a bracket. And why do I use a bracket instead of a parentheses? It can be -4. It's or equal to. So if you see here that you've got a or equal to, that tells you to use the bracket. If it's just a less than or a greater than, you'll use the parentheses. Square roots, always use that bracket right there. Always use a parentheses with infinity, because you can't ever actually get to infinity. It's like a, it's an idea, not really a real number. So always use a parentheses with your infinity. Thinking about this from the graph, if we look at our x-axis here, right here, make this a right here is where x equals -4, and we could keep on going forever up to infinity over here. That graph is going to keep going on forever. So -4 to infinity. Okay, range. From the equation, what you need to look at for range for a square root is this right here. The range of a graph is typically from 0 to infinity. So you need to think about whether or not the graph's been flipped upside down and whether or not it's been moved up, down, left, or right. Now, in this particular case, we've moved this graph down 2. Right? So the very lowest point I can have on the graph right here is at -2. And then it goes up, 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 up forever. So that's going to go to infinity. So I would say -2 to infinity. I think the graph is a little more helpful here than necessarily the equation. Questions on domain and range? Remember, range is the only time you're looking at the y value, right? So all of these are positive, negative, increasing, decreasing. We're talking about the x value. So if we look at positive, we're looking at where this is above the x-axis. And then we're thinking the x value is where that happens. So I'm thinking, like, if I cut this off, you're thinking cutting it with vertical lines, right? I've got, this is at 0. Should I use a bracket or parentheses for positive? It can be that number right there, right? But what is the value of the function right there? Like, what's your y coordinate? What's your y value? It's 0. Is 0 positive? No. So we're going to use, for positive and negative, always use parentheses. Okay, so you might want to make yourself a note of that. So we would say from 0 to infinity. And the reason that we always use parentheses is because whichever point we're using here should be where we hit the x-axis, and our y value is 0, and 0 is neither positive nor negative. So you're always going to use parentheses for positive and negative no matter what type of function you're dealing with. So if we're looking for negative, we're looking for where we're below the x-axis. That's this little piece of the graph. So we're thinking taking vertical lines and sectioning off that section where it's negative. So who can tell me what the interval will be for that? Okay, -4 up to 0. Always print. Oh, I've lied to you. I've lied to you. It's not always parentheses. It's always parentheses where it hits the x-axis. But right here, what's our y value right here at this endpoint? -2. Is that negative? Yes. So we do need a bracket right here. I'm sorry. So let me clarify, because I have messed you up by telling you something that was not true. So if for positive and negative, if the point that you are dealing with is the x-intercept, so like in this case, that 0 was my x-intercept. If it's x-intercept, you want to use a parentheses. If it is the end point, like we see right here, then you're going to use a bracket. Unless the endpoint also is the x-intercept, in which case use a parentheses. So if it's where it hits the x-axis, you want to use a parentheses because that's at 0. 0 is neither positive nor negative. If it's at the endpoint here and it's not on 0, you want to use a bracket because it does include that point. Questions? All right. Square roots are either always increasing or always decreasing. This one, which one is it? Increasing or decreasing? Increasing. So decreasing is going to be none. We'll just mark that out. So it's going to increase on its entire domain. So whatever your domain was up here, you're just going to put it down here for increasing. So from -4 to infinity. Square roots will increase or decrease on the entire domain, so it'll be 1 of 2, just like our exponentials and our logs. Okay, questions? All right, 2 is a natural log, which should be a review for us. So I'm going to let you guys try this one on your own. It can have, this one will have positive and negative. Yeah. These graphs, sometimes they're all positive or all negative, but they can be all positive, some positive and some negative. For increasing or decreasing, it's going to be one or the other. Okay. Let's look at what we've got here. Raven, what would the domain be for this one? Okay. I agree with part of it. I agree with that positive infinity. There. So, with a natural log, do we have a vertical asymptote for this one? We do. It's right here at 0. So that is going to have a vertical asymptote there at 0. Remember, with natural logs, whatever's in here has to be positive. So x has to be greater than 0 for this. So natural logs have vertical asymptotes. Exponentials are always negative infinity to positive infinity. So this stops right here at that x-axis. So we would say 0 to infinity here. Okay, Paul, what would you say for the range? Okay, that is correct. And for natural logs, that's always the answer. Negative infinity, positive infinity for your range. All right, Bo, what about positive for this one? Okay, good. I like that. So right here, it's that little tiny section right there that we're following above the x-axis, and we can section that off from 0 to 1. Okay, so Mia, where would this one be negative? No. But I'm almost glad you said that, because you made a very common error here. So I know immediately that 1 to negative infinity has to be wrong no matter what question I asked you, because when you give an interval, the lowest number has to be first, and negative infinity would be lowest. All right. So what you're thinking of is you're thinking of this is going down, 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 right, which is negative infinity. But up or down is your y value. You're not talking. We want to talk about the x values. So we're just talking about on this x-axis here. Think about those vertical lines. It'd be here, and then I'm going to put one right here, but really over here this is at positive infinity. So we would need a positive infinity there. Watch out for that. Like if there are any answer choices, and I might have done it because it's a common misconception, so I might have put it there trying to trick you. If you see any answer choices where the bigger number is on the left-hand side, that's definitely not it, and you could exclude it from the beginning. So you got to be really careful. Only think about those x values. Think about, don't think about whether it's going up or down. Just think about whether it's above or below the x-axis. So right here, it's below the x-axis all the way over here, which on the x-axis is positive infinity. Okay? Josie, is this one increasing or decreasing? Decreasing. So I'm just going to put a mark through there, increasing. And where is it decreasing? Perfect. It's just going to be the whole domain, so it's the same as the domain there. Good. All right, let's look at a rational. This particular rational has been moved to the right 3 and up 2. Yes. For rational, or no, I'm sorry, for square roots, for natural logs, and for exponentials, yes. So square root, natural log, and exponentials, domain, and increasing or decreasing will be the same. Okay, so for those 3 types, the answer is yes. For this next one, the answer is no. And that is because this one actually, oh no, I take that back. And actually this one is too. We're going to see one that's not. But rationals also, like I was about to say this one switches from increasing to decreasing, but does it? It decreases here because you're always going left to right. Decrease, 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 decrease. All decreases, right? You do have a vertical asymptote where you just skip. But then when you start back up here, you're still decreasing, right? So this one is always decreasing. So just a basic rational is also going to have that same property. But we're going to see one kind of rational where we square the bottom where it's going to be a little bit different. So our domain here with a rational, it's just your denominator cannot equal 0. Basically, think where is this continuous? Like we were doing last night, right? When we were saying where is this continuous? So we got a vertical asymptote at x equals 3, right? Vertical asymptote at x equals 3. So this is going to be continuous everywhere else, right? It exists everywhere else. So it's going to be negative infinity up to 3 and 3 to infinity, everywhere except for 3. Which means this one's also always, it's decreasing everywhere it's fine, so this is also going to be negative infinity to 3 or 3 to infinity. Range. There is only one number this cannot be whenever it comes to y values. Right, because up here we're going up, up, up forever. Right here we're going down, down, down forever. So that's negative infinity to positive infinity. But we've got this horizontal asymptote here. So what value can I not have on my y-axis? 2. Right. So my range is going to be negative infinity to 2 and 2 to infinity. So it's everything except for 2. Just your basic rationals are going to have that characteristic. Okay, questions on any of those? Positive and negative is the hardest for this. Also, it's going to require us a little estimation because I didn't give you a great graph here that you can tell. I will try to make sure the ones on the quiz are ones where you can tell for sure where that's at, where it's hitting it up. It'll be like the last one where it was, or the one before, where it was hitting at like actual good lines, right? I won't give you one that's hitting in between right here. So everything above the x-axis is here, and then it jumps up to here. Below the x-axis is just this part right here. So remember, whenever when we're sectioning this off, we're talking about drawing some vertical lines to cut out that positive part. So the first one, this would be negative infinity down here. So this first one would be negative infinity up to, let's call this 2.5, although it's probably not exactly 2.5. We're estimating, because I didn't give you the best graph in the world, but I'll make sure on the quiz it's not one where you have to estimate. Plus they're multiple choice, so even if I did estimate, just go with whatever I estimated on the multiple choice answer, right? Then I've got this little tiny sliver of pink right here. That little tiny sliver of pink is from 2.5 up to what number? 3. Up to that vertical asymptote that we've got at 3. That part's negative. And then from 3 over to positive infinity, my graph is positive. Okay. Questions? Yes. So for this one, this goes down, 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 down forever, but it's got that vertical asymptote there. So it's going down forever, but it's the x coordinate here, it stops at 3. So if we said from 2.5 to infinity, we would be talking about on the x-axis right here at 2.5 all the way over here to infinity. Right? X values only. Still given just x values. Just x values. Yes. The only time you're going to look at y values for this is for range. Range is the only time you look at the y values. So our x values where this is negative is just this tiny sliver from 2.5 to 3. Okay. Let's see. I want you guys to... Let's look at 5. I'm going to skip number 4 for right now. Okay. This one has been reflected. What would our domain be here? Say that again. Negative infinity to 0. I know I need a parentheses with infinity because you always use a parentheses with infinity. Do I need a parentheses or a bracket with my 0? This point right here is included. Okay, so that end point on the square root graph is included. So we're going to use a bracket for that. So square roots are going to have a bracket for one of your numbers.
Wait, how? But you're never going to have a bracket on an infinity, whether it's positive or negative.
Correct. So no matter what, infinity's always parentheses because you can't get to infinity. It's just an idea.
So in like these situations, so like if it's an infinity and a regular number, the bracket will always be on the regular number.
Yes. Yes. With this natural log, we did not use a bracket. And we did not use a bracket because we got a vertical asymptote there. It never actually gets to 0, right? It gets closer and closer and closer to 0, but it never gets there. So if you have a vertical asymptote, there's a place you're going to use a parentheses. But with square root functions, you have a point right there. So you are going to include that point. It's not a vertical asymptote, so you're going to include that point by using a bracket. Yes? Same thing's going to happen on the range when we start talking about y values. So what's the lowest y value I can have here? -3. Right here on the y-axis, this is the only time we do look at the y-axis. -3 is the very lowest, and it's got a dot right there, not an asymptote. So I'm going to use a bracket for my -3. And then from there, my graph goes up, up, up. It's not going up fast, but it's going up forever, right? So those y values are going to go up to positive infinity. Yes?
Why do we use brackets?
Brackets are like having a less than or equal to sign. It means that that point is included. So it means including -3. So for example, like if I ask you to bring me if I ask you to bring, like, well, let's say that we have, like a ride at the fair, and it says that you can weigh up to 250 pounds. That would include 250 pounds. So, like, if they actually had scales out there and were tested, which I don't usually do, and sometimes you see some people on it that you think maybe should not be on it. But if you weighed 250, you'd be okay. But if it said that so that's like the bracket. 250 is included. You can be 250. If you say that you must weigh less than 250 pounds, then if you weigh 250, you're not supposed to be able to get on that ride. So if you weighed 49.9 pounds, you could get on the ride. But at 250, you could not anymore. So it doesn't include that point. With the square root functions, there is a dot right here that's colored in that we are including in that graph. In the ones where we have vertical asymptotes, we do not include that point there. So another good way to think of it is if, like, it's a dot like the square root, use a bracket. If it's the vertical asymptote, use a parentheses. Okay? So positive here, it barely is positive. It looks like it's at negative 10. That might actually not be right, but it's actually probably negative 9. No, that seems strange. Well, we're just going to call it 10 because this is graph. I'll make sure that it's a little easier to see on your quiz. But this little tiny piece over here is positive. It's above the x-axis. So again, we're thinking x values. X values is like you got vertical lines you're sectioning this off. So that'd be from here, which is negative infinity, over to this point right here where you hit the x-axis. So that is at, we're going to call it negative 10, although I think it's actually a little further off. So we are positive above the x-axis from negative infinity to negative 10. I'm using a parentheses here because at negative 10, my y value is 0. I equal 0 right there, and 0 is not positive or negative. So for negative, I'd have negative 10. Again, use a parentheses for that x-intercept. So x-intercept for these, use a parentheses. If it's an end point, you can include the end point. Use a bracket for that. So from negative 10 up to the end of the graph over here, which is at 0, the graph is negative. Yes. Yes. So the answers you're given are your x values. Only time we're going to look at y values is for range. Is this function increasing or decreasing? Decreasing. So decreasing, it's just going to be whatever your domain was. So negative infinity to 0. Questions? All right. Let's look at number 6. Okay, so this one is a strange graph, but we can see we have a vertical asymptote here at x equals 2. It also looks like we have a horizontal asymptote at negative 2. So when we're talking about domain, we're thinking on this x-axis here. From down here at negative infinity, I've got a graph. I see something all the way up until I get right here, right? And at 2, I've got a vertical asymptote, which means nothing's there, right? So my domain would be negative infinity to 2. I'm using parentheses for vertical asymptotes. We'll use parentheses because they're not included. But then the graph picks back up and is everywhere else. So 2 to infinity. You could also think about this how we were doing yesterday. That denominator, x minus 2 squared, cannot equal 0. So you'll get 2 being your discontinuity. That's the one you're throwing out. Yes? So these, like, they kind of look like there's a gap in between them, but assume anything you see that looks like an asymptote is. So as it continues on, it's going to get closer and closer and closer and closer and closer. So eventually, it's going to be almost at 2, but not there. It might be 1.9999999, right? So so even though it might look like there's a little bit of the gap on the graph, that's an asymptote. So go ahead and just go with that 1 point. Okay, range, we're thinking about y values. What's the lowest y that you see on here? -2. Bracket or parentheses? We've got an asymptote right there, right? So asymptotes, use a parentheses because it never actually quite gets to -2, even though it's going to look like it does because asymptotes look like they get there, but they don't. Because it's actually right there like -1.9999999, which we can't tell the difference with our naked eye there. But and then what's the highest y value I can have? This goes up, 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 up forever, positive infinity. So range is the one time we're thinking up and down, looking at those y values. I'm not going to give you positive and negative one like this when we're running out of time, so I'm going to skip it. Here is the one, though, that you're going to see it actually does switch from increasing to decreasing. It's not just the domain here. So this graph, it increases from negative infinity up to 2. I'm going to use a parentheses there because it's an asymptote. But what does it do after it gets past 2? We're decreasing here. So from 2 to infinity, we're decreasing. Again, you're thinking x values for that. Okay. So, gosh, I hope this works because it's so hectic. All right. So your assignment is to do a quizzes, which I tried to make a class for you. Let's see. Where are we at here? Okay, let's see. Alright, so I think if you click on this join code for the class, it is going to take you to the class. Then there should be one called 2.4 Features of Functions quiz that I have assigned to you that you can do. It's okay that I assigned it like a homework, so it's okay that we didn't get to it in class. So please, if this is not working, since we didn't get time to test it out in class, if it's not working, somebody send me an email and let me know so I can try to get that fixed for you. I think it should work, hopefully, but since I haven't started it yet this year, I can't tell. It's not going to be pretty much. It's just we looked at square roots and fractions. I had not seen it before. The other ones were lots of examples. Same thing, just different types.
Major, how's it going? Failure of a rectangle. This ain't no camp here.
We're finding a few totem poles. We're also noticing that the kids that have you, the long desk